So in my presentation today, I'm going to come back to one of our favorite themes throughout the symposium, and that's that of climate change. And in particular, I want to focus on what it is that we might be able to do about it in terms of biodiversity conservation. So we all know that climate change is a pervasive driver and that it does absolutely require reductions in global greenhouse gas emissions. But the question that I want to be looking at is what are some of the local and regional strategies for biodiversity conservation under climate change? And this has been alluded to throughout the other talks as well, and I think it's an important issue because we often get the questions, well, you know, we're very good at documenting these train wrecks, but not very good at giving ideas of what to do about them. And one of the things that I've become interested in is exploring how the spatial patterns of climate change are being projected and how consistent those are, so I'll spend a bit of time talking about that. So the two key questions or themes in my presentation is how consistent are these climate change projections across scenarios and across models, and that will give us a sense whether we might need different conservation strategies in areas that might have different susceptibility to climate change. So, and I'll be using the Coral Triangle as sort of an illustrative example of some of these issues. So what I've done is looked at some of the IPCC scenarios and focused on three of them, a sort of high emission scenario, the A2, intermediate emission scenario, A1B, and a more optimistic scenario, B1, to get a sense of what these global climate models are predicting. I focused on sea surface temperature for this, and most of these models have a 100-year modeling time frame. And one of the nice things about the IPCC models is that all of them are actually freely available, and it's a resource that I think we don't take very much advantage of in conservation planning or conservation biology to date. So I downloaded about 20 models that are relevant, and some more so for some of the scenarios than others. And I analyzed two types of trends in these. One of them is the rate of change over those 100 years. That's essentially the slope of a regression equation that gives the rate of change. So it's a linear indicator, and the other one is nonlinear, and it's an indication of the consistency of change that we're seeing, in this case for sea surface temperature, which is simply the number of times over the time scales, time steps in these models that we see an increase versus a decrease. So here's sort of the culmination of all of those as a multi-model and multi-scenario ensemble of them. And the Coral Triangle here is in a rectangle. But this gives you a sense that there is a fair bit of spatial variation, even when you combine all of those three scenarios and all of these models, and that this region is sort of an intermediate climate change projection. This is for the consistency of change, and the tropics are projected to change quite consistently. So almost every time step we see increases in temperature, whereas in some of the other regions it's much less so. And then what here goes. Those are those two maps again. I was also interested in comparing how these projections over 100 years compare to what we've seen to date. So we have data from satellite imagery from 1982 onwards. And these are the two maps I'm going to put up on the side here in the same scale as what's on the left. And what you see, what jumps out in these two, what we've seen to date, is there's a lot more spatial variation than what's projected. And in the Coral Triangle region, there's some spots that are that so far have increased at quite a fast rate compared to other regions, and they've also increased quite consistently. But teasing apart some of these projections into the three scenarios, you're going to have the rate of change and the consistency of change. And the basic take-home message is that across these scenarios, the spatial patterns that we see are pretty well the same, even though the magnitude is different. So it doesn't really matter which projection we're on, which of the scenarios we're following in terms of the spatial patterns we're likely to see. So this helps us, at least in some way, move forward with knowing which parts of the world are more likely to be changing much faster than others, which can guide some of our conservation strategies. Here's just a snapshot, 2 slides that show you all of these different models. It also shows you that some of the models have very coarse resolutions and others are much finer. Main take-home message with these is that the magnitude of the changes are roughly the same across these various models. The spatial patterns vary a bit, but roughly some of them are fairly similar for some regions, less so for others. And this is for the A2, for the rate of change. Whereas for B1, the magnitude that's projected is quite different across some of these scenarios. So what I wanted to focus on here is that for the Coral Triangle region, you can see that they likely have sort of average or slightly higher than average impact from climate change, and that these projections are fairly consistent across models and scenarios. But of course, climate change doesn't occur in isolation, and especially in the last few talks, what we've heard is that there are a lot of other drivers of change as well, such as globalization, human population growth, fishing, and so on, which gives us, of course, the main message that the future is going to be very different from the past. And this, of course, you can always say because the future is always different from the past, but in this case, I think it will be even more so because the environment is changing while human populations and the development is changing as well. So I'm going to focus a little bit on some of the conservation strategies that have come up in light of some of these climate change issues. And when I talk about conservation, usually the main aim is to limit or halt biodiversity losses. But more increasingly, there's also an additional focus on maintaining ecosystem services and ensuring sustainability of livelihoods and fishing and so on. So there has been some innovative thinking on this already, and one that I wanted to put up is from Tim McClanahan and others, including some co-authors in the room here, where they suggested that perhaps there's a different range of the kinds of conservation or management actions that you might want to do, depending on the environmental susceptibility, so those kinds of maps that I put up earlier. Some places are more susceptible than others. But also the social adaptive capacity, how well the human communities might be able to cope with that change. More generally speaking, though, the focus in the conservation literature has been primarily to still ignore climate change. So there's a lot of studies that have sort of the business as usual. We know climate change is happening. We don't really know how to deal with it. So let's proceed the way that we have done in the past. There's also an increasing focus on arguing that marine protected areas reduce non-climate change stressors, and therefore they might increase resilience to some of these climate change related stressors. In terms of conservation planning, that means pretty well business as usual. You just have an additional argument for why you need MPAs. And there's contradictory evidence whether MPAs actually increase resilience to climate change stressors. It seems to be the case in some regions, perhaps not in others, so the jury is still out on that in some sense. There's also an increasing move to try to identify what's being dubbed as refugia, so places in the world that might be warming less quickly than others under climate change scenarios. And we can define these spatially and try to target them when we come up with new places for protection. So let me just give you one example of that, focusing on the Coral Triangle region. So with coral reefs, you might want to take the threshold of 1 degree above the average summer temperatures as your common bleaching threshold, and you can take these climate change projections and say, for example, that we want to include or select some of these refugia by targeting these areas that are below that threshold. And you can do that in some of the conservation planning tools and identify some regions that might be of higher or lesser importance as refugia under climate change. And these black lines are simply outlines of ecoregions in this example. So it's one of the ways in which you can start to incorporate climate change into the way that conservation planning is commonly done. There's also some move to think about the range shifts you might be seeing, so to model those, identify the corridors that might link current populations and into future populations and include those in your ideas about marine protected areas. And similarly for connectivity, to identify sites that would be good under different future scenarios for connectivity that you might want to protect no matter what scenario is occurring. But all of these still focus on MPAs largely. But there's a lot of other thinking that's starting to happen as well as climate change is becoming more severe, and I wanted to focus on some of those and sketch them out in this sort of a schematic of the uncertainty of the effectiveness of some of these, and then sort of a rough sense of the relative financial cost of them. So below here you have the in situ conservation area, such as your MPAs or other kinds of spatial management, such as seasonal closures, taboo areas, and that sort of thing. So these, relative to some of these others, we know they're fairly effective if they're complied with and relatively low cost. I've put up some aspects of restoration here, which in the coral reef community can be a bit of a dirty word sometimes, because it implies that it's okay to destroy reefs because we can restore them. But here simply what I mean is that you can have some areas that have been destroyed or that are quite degraded, set them aside, remove other stressors, and hope that they come back, which is essentially what passive restoration is. We don't know how effective that is, usually not quite so much. With active restoration, it gets to be quite expensive if you try to have active management in those areas. Don't quite know how certain it is, fails in many cases. Assisted colonization is quite controversial, would be quite expensive to do. We don't quite know how effective it is. But as some of these other options become less and less available as climate change goes on, some of these are becoming potential options. There's also some talk about ex situ conservation with the intent, so in aquaria, for example, with the intent of reintroducing species where they might get extirpated, and a whole bunch of in situ mitigation strategies that are being proposed, ranging from very local shading of reefs, for example, to buffering of oceans to reduce acidification, potentially quite risky, would be very costly to do, and don't really know how effective they might be. And then if it's really dire and all you want to do is conserve the genetic material, you can have various genetic banks. We know they would preserve the genetic material, but in terms of persistence of biodiversity, not quite what we're aiming for. But still, all of that only focuses on the species and doesn't consider the human element of this, because ultimately we're really talking about people having to manage their resources. So I wanted to put up a few ideas out of a workshop last year in terms of thinking about governance of some of these systems and the kinds of themes that are coming forward, which link into some of what Bob was talking about earlier as well. So for example, we need to start looking into the future a lot more than we have, and we can use tools such as scenario development, experimentation, innovation at multiple scales, so allowing communities to come up with some strategies that they might be interested in, and seeing how well those work and encouraging some of the innovation at those very local scales. We also know that we need to be really people-centered in terms of how we do management and governance. Because if you identify, as Bob was saying, a very ideal regional network, and you try to implement that, it fails most of the time because you haven't engaged with the people there. So we need to be cognizant and we need to be quite inclusive in our approaches, responsive to multiple objectives that people might have, including various livelihood objectives, and cognizant of human rights as well. And this is particularly important in a place like the Coral Triangle, where so many people rely on food for their subsistence. And then finally, political engagement is also really crucial, again, especially in the case of the Coral Triangle, where at the moment you have a lot of high-level political buy-in, and that might change as political leaders change, and you don't know if you might lose that quite quickly. So investment in political processes and institutionalizing the fact that a lot of things are going to change over time, so adaptive management and some of those other tools, as well as focusing not only on the sexy threat at the moment, whether it's climate change or overfishing, but all of the suite of things that are actually changing the systems, people's livelihoods, the ecosystems, and so on. So just to sum up and to bring some of this together, I've tried to focus on climate change as one of the big threats and how we might include that in terms of our thinking of biodiversity conservation. And some of those global climate change models are quite useful tools to do that, because they give us a sense of how consistent climate change might be in different parts of the world. And in the Coral Triangle, it seems as though the forecast is relatively dire. And you can see that there's been more change, and the change in the past has been more spatially variable than what's projected into the future. So we'll probably see some of those spatial variabilities continuing as well. But ultimately what we need, I think, are multiple and diverse strategies for management and conservation. MPAs are quite sexy, and they're, you know, we as conservation biologists like to say that they're good things to implement, but the realities in some places are that those by themselves are definitely not going to be the only tools available, and they might not even work where people rely on resources to such an extent that, you know, they simply can't give up fishing. So we need to focus on, we need to explore and focus on experiments and novel approaches, and allow communities also to come up with some of their own approaches and foster that sort of innovation and then spread some of that. So thanks very much.